Hello, welcome to Block 3, Equality and Equivalence, Lesson 6. I'll share my screen. So, in your previous lesson, you learned the meaning of like and unlike terms and how to identify them in algebraic expressions, or how to identify algebraic terms that were like terms or even unlike terms. In today's lesson, you're going to learn about the meaning of equivalence. It's a very important concept in your understanding of algebra and even in maths in general. But before we start, I would like you to pause the video for 3 or 4 minutes and have a go at the retrieval practice questions. So take note, these questions takes you back in time, okay, to think about the things you learned in previous lessons. All right, so I'm going to assume you've paused the video and you've really worked through the questions. Here are the answers. Let's discuss them. So here, you're asked to substitute 4 for t. That's what substitution means. So if you haven't watched the video, you can go and watch our substitution video. So it means wherever t is, we're just going to replace it with 4. And you should know how algebraic terms are written. So 5t means 5 times t. Yeah. So that will mean 5 times 4. And then this one will mean 10 divided by 4. This will mean 4 divided by 10. And then this would mean 4 minus 4. Here you're asked to substitute h. Okay. Substitute 11 for h. And then we'll do the same process. The only difference between question 1 and question 2 is question 2 is two-step substitution. So again, if you haven't watched that video, you can go and watch it and learn how to do substitution properly. So this will be 4 times 11, and then you subtract 5. This will be 2 times 11, then you subtract it from 35. And then this will be 11 squared, so 11 times 11, yeah, minus 12. For question 3, you were asked which expression is represented by the bar model. You remember our bar model, we always add. Okay, we'll add our bar models. So this will be k at 7, but we have 3 lots of it, so we can write it as this one. Okay, this one. Now, remember, if we put the k's together and the 7s together, we will have this 3k, because k plus k plus k is 3k, and then 7 plus 7 plus 7 is 21. Another thing I want to show you, I like showing you interesting things that you would obviously come across or use in the future, but I think you should know it now. Yeah. This here, we could have done, I've shown this before. We could have done this like this. That's how we get that. So whatever is outside can multiply what's inside. Okay. So that's why it's going to be equal to this. You see? Because 3 times k is 3k, and then 3 times 7 is 21. Something important I think you should know. We'll use it in the future. Let's move on and do some new learning. Okay, something you need to know. 2 expressions are equivalent if those expressions are equal for all values of the variables in each of the expression. That's a lot of words. Okay, let's see what it means in practice. So if I have 3k at 7, yeah, 3 lots of k at 7 and 3k plus 21, if we want to check these, whether they're actually equivalent, we can actually substitute numbers in and check whether the left will be equal to right. Okay, so this is what it is. This is what it looks like. Originally, when we put it together, this is what it looks like. This is the first one and this is the second one. So if we put in, let's say, for example, 5, are they the same? Are they equivalent? Of course they are. What if we put in 10? They're equivalent. So remember, expressions are equivalent if they are equal for all values of the variables in each expression. So regardless of the value we put in to the left or to the right, we get the same result. What about this one? Same results. Now, because they are equivalent, the way we show it in algebra is we use 3 horizontal lines. So remember, when they say state equivalence, this is how it is shown here. Okay? All right. All right. So that's how it's shown. All right. So you've learned so far what equivalent expressions must be. Equivalent expressions must have the same value, must be equal for all values of the variables in the expressions. All right, time for you to have some practice. Pause the video and have a go at question 1 for 2 minutes. Okay, assuming you've paused the video and you've really worked hard through this, here are the answers. Let's discuss them. Question 1, you were asked to complete the table. So this is again substitution. So you want the value when y is 5, and here you want the value when y is 9. Okay, and here is what you get. By now you should know how to do substitution. If not, you can go and watch our early videos. And then here you're told to look at each column, which expressions give the same answer. All right, which one give the same answer? Then you can clearly see those. Okay, and then you ask, why do you think this is the case? Okay, of course, that's the case because of equivalence. And then here, you say which expressions are equal to 8p? All right, which expressions are equal to 8p? So remember, you can check your answer by substituting several values of p. So you can take any number, 1, 2, 3, 0.1, just to check. And these are the expressions. All right, so p plus 7p is 8p, 4p times 2 is 8p, 4 times 2p, these are commutative, then that one. Okay, these are equivalent expressions but written in a different form. All right, let's do some new learning. Now, if we have the expressions, okay, the expressions are equivalent to 8p. So if I ask you to complete these expressions, what will you come up with? Okay, now if we think about the bar model, so if I write 5c, but I don't know what 5c will be, what is needed to complete 5c so that the bars are of the same width. One way to think about it is, okay, what if I do 8c minus 5c? Because if I take this slice off, then I can find out what's left. Of course, that gives us 3c. What about these ones? Have a think, complete them, let's see what we get. Okay, what are the missing terms that would make it equal to 8c? All right, let's discuss them. If we think about this one, if we have 12c, again, if I take a slice of 8c from 12c, which is the same thing as saying 12c minus 8c, I'll get 4c. Okay? This one, I need something that I need to put here such that I will get it equal to 8c. So another way of thinking about it is to say, what if I do 8c divided by 2c? You say, what? I haven't seen that before. Okay, you need to know that that is possible. Okay, so we're going to get 4. Next, this one is another way of thinking about it is to say, what if I take 7c slice of 8c? I'll have c. We don't write 1c, or actually it's 1c, but we don't write 1 next to the letter. We just know it is. A bit just the same way I expressed earlier that when we write powers, we know c has power 1 if we're dealing with powers, something having to do with powers, but we don't write it. And then 24, we're thinking, all right, what do I need to divide 24c by to get 8c? Another way of thinking about it is to say, what if I do 24 divided by 8c to find out what lots of 8c I need, how many lots of 8c I need to make up 24c? That's another way of thinking about it. And you have 3. Okay. Here is another one, another example. 3p and 6p is equal to 18p. Yeah, it's equivalent. That's what Jack is thinking. Because when p is equal to 1, both expressions are equal to 18. Are you sure it's correct? Have a think. Of course, Jack is not correct. Here is why. If we test with different numbers, we'll see that 3p times 6p will give us these. Yeah. Remember, when you check equivalent expressions, you can check with different numbers. But check this out. Yeah. So this is 18p. Yeah. So this is, this is 3p times 6p. So when we check it, we seem to get different values. Okay. Now, another way to think about it is if I decompose this and write it the way it should be. So 3p times 6p means 3 times p times 6 times p. If we put the numbers, yeah, the constants, by now we're using the right word, and the variables, yeah, we'll multiply the variables and the constant. This is what we get. So you can clearly see that 18p squared is not the same as 18p. They're not the same. Yeah. All right. Let's move on. All right. What you've learned so far before you have a practice and the questions is that for you to test whether expressions are equivalent, you can try using different numbers. Okay. And always remember the principles of algebra. Here are questions 3 and 4. Pause the video and have a go at these questions for 4 minutes. You can do it quicker than that. Okay, assuming you've paused the video and you've really thought about these questions, you've worked hard, here are the answers. Let's discuss them. Here you were asked, each of these expressions should be equal to 10m. Complete the expressions. Well, if we're adding something to 3m to get 10m, so another way to think about it is, remember our knowledge of inverse operation. If it has to be 10m, well, we can do the inverse. We can say, okay, let's do 10 minus 3m to find out what's missing. Same with these. Here we can do 10m divided by 5m to find out what's missing. Here we could have done 10m minus 6m. Here we could have done 50m. So if we're looking for what we're going to be dividing 50m by to get 10m, we could do 50m divided by 10m. Okay. Here we could do 10m add 6m to find out what should be there. And here we could do, if we're looking for what to take away, then we could do 12m minus 10m. Okay, to find out what needs to be there. Okay, that's another way of thinking about it. All right. And then here are the answers for 10b. So here you told to write 5 expressions that are equivalent to 24ab. Okay. One has been done for you, this one. Yeah. So that one. So remember to have equivalent expressions. You can write them in different forms, and then you can make sure that when you test the numbers, when you test with numbers, your expression must give the same values. Okay, let's move on. Here is the answer to question 4. Here you're told to work out the expressions below for several values of g. And then here you just need to test with values. Yeah. And then you can see that these are equal. Okay. Again, remember, I don't want you to forget this. We could do this. Whatever is outside can multiply what's inside. So that's 4g add 20. Don't forget that. You come across in the future. Okay, so remember, you've been asked to do the rest of the questions. So far you've done questions 3 and 4. Here are questions 5 and 6. Pause the video and have a go for 4 minutes. Okay, assuming you've paused the video and you've really worked hard, you've thought about this through, here are the answers. Let's discuss them. For question 5, you're asked, circle the two expressions that are equivalent to 3x plus 6. These ones. Addition is commutative. That's what it's taking advantage of there. And here, this one. Remember what I explained the other time? These out here can multiply that and that. Yeah? Okay. And then B, you're told circle the two expressions that are equivalent to 8y minus 20. Okay? These, you see that? Because 4y plus 4y is 8y, and then minus 20 is still there. Then this one. Again, remember, these outside, you could have checked it by saying, okay, let me use that thing that Mr. Oteri talked about. So this one times that is 8y. This one times that is minus 20. Yeah, so they're the same, they're equivalent. Okay. And then question 6, you were asked, are these statements true or false? So you're being asked whether they're equivalent or not. Okay. So we can see they're equivalent. That one is equivalent. 7x minus 2x is 5x. 7x minus 2x is not equivalent. So they are false. Let's move on. Question 7 and 8, pause the video and have a go for 3 minutes. So here you ask, are the expressions 3a and a to the power 3 equivalent? Of course, no. So assuming you've paused the video, you've worked through it. So here are the answers. Let's discuss them. Of course, no. They have different powers. Straight away, that is obvious. Or another way, you could test with value. So for example, if you put 1, you see that, okay, 3 times 1 is 3. 1 to the power 3 is 1. So they are not equivalent. Because remember, the rule for equivalence, they would be equal for any values of the variables in the expression. Alex is looking at expressions. Here, Alex says p squared and 2p are not equivalent expressions. However, p squared and 2p can be equal to each other depending on the value of p. Alex is correct though, but what does the value of p need to be to make the expressions equal? Okay, this is the bit where I want you to pay close attention, because I want you to start. You've been learning a lot about algebra, so let's start doing some work. So if these have to be equal, we can write it like this. Okay, so that's how we start to make our assumption. Okay, we want to make them equal. If they are going to be equal, this is the same thing as p times p is equal to 2 times p. All right, but we want to find out the value that will make them equal. Okay, we want to find out the value. So here is something I want you to think about. We could get, if p shouldn't be here, we could say, well, let's cross out 1p from both sides, because that way we'll just have p is equal to something. So by doing that, we have divided there by p, and we have divided that by p. So this looks like this. P times p divided by p is equal to, see that we're doing the same thing all the time, 2 times p divided by p. So that p is now gone. That p is now gone. So the thing that is true when both expressions or both terms are equal to each other is p. You can see p is left and 2 is left. So p is equal to 2. Okay. So I hope you take note of that, how we solve that problem. It's really important you begin to take note of little things like this. All right, here is question 9. I want you to pause the video and do question 9 in 2 or 3 minutes. Okay, assuming you've paused the video and you've worked through question 9, you've really thought about the solution. Here are the answers. Let's discuss them. Here you ask to tick the pairs of expressions that are equivalent. It's obviously this one. Remember, commutative. The order of the variables does not matter. They are equivalent. And you could have tested it with numbers to see whether the term in the left will be equal to the term on the right. These are not equivalent. Yeah, remember? The rules of algebra, you could use bar model to check it. Okay. All right. This brings us to the end of our lesson. So far in our lesson, we have learned that equivalent expressions are expressions that are equal for all values of the variable in the expressions. All right. And we've applied some rules of algebra. You've also learned some really, cool techniques of that you should know. Well, even though it's in advance of what you should know, but you need to start to know these because you're building really strong foundation in your understanding of mathematical concepts. Okay, until next time, take care and bye-bye.